This video is going over examples of questions that are going to appear on your IB exam on linear equations. First of all, you should be familiar with terminology. Linear equations, the first one is gradient intercept form. For IB purposes, gradient is slope. So slope intercept form is gradient intercept form. It's y equals mx plus c. Instead of y equals mx plus b, it's y equals mx plus c. C is still the y-intercept and m is still the slope. So already there we see a few changes between Algebra 2 and IB Math. The other one is point gradient form. Point gradient form is y minus y1 equals m times x minus x1, where m is the gradient, x1, y1 is basically a point on the line. This one still looks exactly the same. The only difference is that instead of slope, we're saying gradient. Finally, we have what's called general form, which is our standard form. It's now going to be ax plus by plus c equals 0. And in order for us to have this written in standard form, there are 3 requirements. Do you remember them? One of them is going to be that your x is going to be positive. And when I say x, I mean the coefficient in front of x. So technically a, basically. So your x is positive. There can be no fractions or decimals in your answer. And it has to be set equal to 0. So those are the 3 requirements in order for you to have this written in what's called general form. Special lines, horizontal lines, are the ones that go left to right. A horizontal line has a slope of 0, a gradient of 0. Remember, there are zeros in the word horizontal. And a vertical line has an undefined slope. Vertical lines go up and down. And the reason why vertical lines have undefined slope is because it's always rising, never running. So you're going to end up with an answer that has a number divided by 0, and division by 0 is mathematically impossible. So that is why we say that the slope, the gradient, is going to be undefined, and anything that has just an x and no y is going to be a vertical line. Let's look at a quick example. Find the equation of the line that passes through the point 3, 31 and has a gradient of 12. Write the equation in gradient intercept form. There's 2 ways that we can approach this problem. The first way is using point gradient form. Point gradient form is y minus y1 is equal to m times x minus x1. Because they give me a point and I know the gradient is 12, I can go ahead and directly substitute into the equation. I'm going to replace y1 with 31 because that's the y value of my coordinate. M is the gradient, which is 12. X stays in your equation, and then you replace x1 with the 3. Had they not asked us for gradient intercept form, this right here would have been my final answer and they would have accepted it. However, because they were very specific and they want this in gradient intercept form, which is y equals mx plus c, I'm going to have to distribute and get the y by itself. When I distribute, I get y minus 31 equals 12x minus 36. Add 31 to both sides, and I'm going to get y equals 12x minus 5. So now this is my same equation, just written differently into what's called gradient intercept form. What's the second way that you can approach this problem? You can go straight into y equals mx plus c. You're going to replace the y with the y coordinate, replace m with the gradient, and x with the x coordinate so that you solve for the y-intercept. I get 31 equals 36 plus c. Take away 36. I get negative 5 is equal to c. So that is my y-intercept, and my equation is going to be y equals 12x minus 5, which is exactly the same answer I got when I went through point gradient form. For part B, it says find the linear equation in C and F, knowing that when C equals 10, F equals 50, and when C equals 100, F equals 212. Solve for F in terms of C. This right here, you have to pay a lot of attention to. What does that mean? Solve for F in terms of C. That means that you want an answer where you have F equals something that has the letter C in it, which means that my C is my X and my F is my Y. So my 2 points here are going to be 10, 50. So it says when C is 10, F is 50. And I'm going to have 100, 212. The first thing that I want to do, because I have 2 points and I don't have the gradient, is first, let's go ahead and find the slope. You need to find the gradient. The gradient formula is in the formula packet. It's y2 minus y1 over x2 minus x1. So the way this works is that I'm going to call this my x1, y1. Remember that every single ordered pair is x comma y. I'm just making the distinction between my first point and my second point. So that's why that one is x1, y1, and this one is x2, y2, okay? So here, my gradient is going to be y2, which is 212, minus y1, which is 50, over 100 minus 10. Go ahead and put this into your calculator. You're going to get 162 divided by 90, which we can simplify in the calculator instead of writing it as a decimal. As a decimal, it's going to be 1.8. But as a fraction, if in your graphing calculator you press math frac, it's going to give it to you as 9 over 5. Now, I don't have the y-intercept, and so I do need the y-intercept. One of the things that I can do is still go through point gradient form. So let's go ahead and let's just do that part. Here, I'm going to pick one of the points to work with. I'd rather work with 10, 50 because it's smaller, although you're going to get exactly the same answer even if you work with the other point. One of the things that we can do to figure out this equation is go through point gradient form. So y minus y1 equals m times x minus x1. In this case, I'm going to replace the y with f, because remember we said that it's going to be f equals something that has the letter c in it. And then for y1, I'm going to use the 50. M is going to be my gradient, 9 over 5. And I have x, well, instead of x, remember, I almost messed up myself. Instead of x, we're going to use c because they told us that they want it to be f in terms of c minus x1, which is 10. So now I have the equation with the letters f and c where they belong, and I can go ahead and solve for f because it says solve for f in terms of c. Another thing for us to remember is the fact that lines that are parallel are going to have the same gradient. They're going to have the same slope. And when you have the lines that are perpendicular, you're going to have gradients that multiply together to equal -1. We call those negative reciprocals. That's where we get that if the first slope is, let's say, 3 over 4, the perpendicular slope is -4/3. Okay, so you flip it and change the sign. If the first slope is +2, remember that +2 is the same as 2 over 1. So that means the perpendicular slope is -1/2. Example 2.4. Consider the straight line with equation y equals 3 over 5x plus 2. Find the gradient and the y-intercept. First question, very easy because they already give it to me in y equals mx plus c form. Had they not given it to me in y equals mx plus c form, I would have first had to get the y by itself. So here, I know that my gradient, my slope, is the number that's next to the x when the y is by itself. So that means that my gradient is 3 over 5, and my y-intercept is going to be 2. Part B, find the equation of a line that passes through the point 1, 5 and is parallel to the given line. We said that when lines are parallel, they're going to have the same exact slope. So here, my job is to find the equation of a new line that passes through the point 1, 5, but if it's parallel to the line they gave me, then I have to grab its slope and it has to be the same exact slope. So the slope I'm going to use in my problem is going to be 3 over 5, and it has to pass through the point 1, 5. Again, you have a choice here. Remember that you can always go through point gradient form, which is y minus y1 equals m times x minus x1. I find this one to be just so simple for you to substitute. So I write y minus 5 is equal to 3 over 5, parentheses x minus 1. And this would be the final answer, believe it or not. They would accept this on the IB exam because they didn't tell you the specific format they wanted for this equation. So this right here would be a perfectly good, reasonable answer. If you really want to get the y by itself, you can. You would have to distribute. So for example, in this case, I would have to distribute 3 over 5 to both the x and the negative 1. I get y minus 5 is equal to 3 over 5x minus 3 over 5. You're going to add 5 to both sides. This is something that you can just do in your calculator. In your calculator, y equals 3 over 5x. When you add 3 over 5 plus 5, which is 5 over 1, I'm going to do it by hand, but you can just totally do it in the calculator. Because I want my two denominators to match, I'm going to make the bottom one 5. And if I multiply 5 times 5, it becomes 25 at the top. So 25 over 5 is the same thing as 5 over 1. And now negative 3 plus 25 is just going to be plus 22 over 5. Okay, so if you really want to get it into slope-intercept form, gradient-intercept form, you can get the y by itself. And again, don't get alarmed, don't get scared about the negative 3 over 5 plus 5 because your calculator will do that for you. What's the other way that you can do the problem? You can go directly into y equals mx plus c form where you substitute the y with 5. The gradient is 3 over 5. X is 1 plus c, and you solve for the y-intercept. So 5 equals 3 over 5 plus c. In this case, I'm going to subtract 3 over 5 from both sides. 5 minus 3 over 5. Remember, we said we're going to do this in the calculator, but 5 is the same as 25 over 5 minus 3 over 5, which is 22 over 5. So I get y is equal to 3 over 5x plus 22 over 5, which is exactly the answer that we got before. We're going to go back now to finish part C, and part C is different because now my equation is going to be perpendicular to the given line. The only thing I want from the line they gave me is its slope, because if it's parallel, then I knew my other new line is going to have the same slope. But now because it's perpendicular, instead of working with a slope of 3 over 5, my perpendicular slope is going to be negative 5 over 3. But I'm going to do exactly the same thing because it's passing through the point 1, 5. So for point slope form, y minus y1 is equal to my slope, my gradient, times x minus 1. This would be perfectly fine for you to write as your final answer because there was no indication in the question of what exactly you had to leave it in what form. If you want to get the y by itself, no problem. Let's go ahead and distribute. Y minus 5 equals negative 5 thirds. X plus 5 thirds. Go ahead and add 5 to both sides. In this case, my denominator is going to be 3 that I'm trying to get the 5 to have 5, something with 3 in the bottom. So I get negative 5 over 3x plus, when you put this in your calculator, 5 over 3 plus 5, which is 5 over 1, I need to make the 1 a 3, so I multiply the top by 3 and I get 15. 15 over 3 is 5. So that's going to give me 20 over 3 as my y-intercept. And if you really want to get it into y equals mx plus c form, there you go. That's going to be your final answer. In this question, line L is given by the equation 3y plus 2x equals 9, and point P has coordinates 6, negative 5. Explain why point P is not on line L. How can I tell if a point is or is not on the line? Well, we're going to use substitution. So here, remember, for my point 6, negative 5, x is 6, y is negative 5. So let's go ahead and substitute. So for part A, I'm going to say 3 times y, which is negative 5, plus 2 times 6, and I'm trying to check if that in fact does give me 9. 3 times negative 5 is negative 15. 2 times 6 is 12. Okay. And so I get negative 3 is equal to 9. That is not a true statement. Therefore, that is why it is not on line L. For part B, find the gradient of line L. You can't just say, oh, it's going to be 2 because it's next to the x. No, you can't do that. You have to get the y by itself first. So to get the y by itself, if I have 3y plus 2x is equal to 9, I'm going to subtract 2x from both sides. I get 3y is equal to negative 2x plus 9. Divide everything by 3. So now I get y equals negative 2/3 x plus 3. Remember that we have to answer the question. The question is to find just the gradient. The gradient is negative 2/3. Part C, write down the gradient of a line perpendicular to line L. We know that perpendicular lines have negative reciprocal slopes. So if we just found the gradient of L to be negative 2/3, that tells me the negative reciprocal, you flip it, change the sign, is going to be positive 3/2. Find the equation of the line perpendicular to line L and passing through point P. Okay, read that again. Find the equation of the line perpendicular to line L, which we just found that that's going to have a gradient of 3/2 because we determined that in the last part. And it has to pass through point P, which they gave me as 6, negative 5. So for part C, part 2, I'm going to go ahead and put y minus y1, which is negative 5, is equal to 3/2 times x minus 6. Negative is a positive. That would be the answer. I keep telling you this. If they don't tell you how to write the answer in what form, they will take point slope form as your final answer. I'm going to go ahead and distribute just for those of you who either go straight into y equals mx plus c or you want to see it as y equals. So now I'm going to distribute 3/2 times x and 3/2 times negative 6. I have y plus 5 is equal to 3/2x. That's going to give me negative 18/2, which is negative 9. Now I have to subtract 5 from both sides. Good news, we don't have any fractions there to worry about. So 3/2x minus 14. And this is going to be my answer in slope-intercept form. Just for fun, so that we can practice, how would I write this in what's called general form? In the form ax plus by plus d is equal to 0. Remember, there are 3 requirements. Number 1, the x has to be positive. Take a look at your answer. The x is positive, so I'm not going to touch it. Number 2, there can be no fractions or decimals. I definitely see a fraction. So what I'm going to do to solve that problem is that I'm going to multiply everything by 2 because 2 is my denominator. So the entire equation, you don't get to choose what you want to multiply by 2. It's all or nothing. So I multiply the equation by 2. I get 2y equals 3x minus 28. So I took care of the fact that x is positive. There are no fractions or decimals. And the last requirement is that it has to be set equal to 0. So my final answer is going to be 3x minus 2y, because I took the 2y over, minus 28 is equal to 0. So let's review. If you were doing this for the exam and they didn't ask you for a particular form, they would have totally taken your answer right here of y plus 5 equals 3/2 x minus 6. If they would have asked for slope-intercept form, which is gradient-intercept form, you want to get the y by itself, y equals 3/2 x minus 14. And if they want general form, then you have to make sure that it meets those 3 requirements of having the equation set equal to 0, x is positive, and there are no fractions or decimals, so you would have to write it in this form, 3x minus 2y minus 28 equals 0. Okay, this is going to be our last problem. This question is more representative of how they ask you the questions on the IB exam. The equation of the straight line L1 is y equals 2x minus 3. Write down the y-intercept. When it's right down, it should be pretty easy, something that you just kind of see and get written down. Really no work needs to be shown. So write down the y-intercept. Here the y-intercept is just negative 3. Part B. Write down the gradient of line 1. The gradient in this case is going to be 2.